Another thing you might be asked to do as an analyst, and we've seen this a lot of times over the years here at Femap, is to reduce a mesh down to something more appropriate for just representing stiffness and mass for a dynamics analysis. So this is actually a pretty fine mesh that might be pretty good for stress type work. But let's say my assignment today is get this down to a lot less nodes and elements that we can put it into a larger system model for dynamics. So this is where the geometry from mesh may come in handy. So I'll just start again. Let's do the whole thing, turn it into geometry. So I'll say surface from mesh, and the first thing we'll do is I'm going to pick the big planar area and turn that into a mesh. So Femap's got this nice little tool where I can pick one face that I like and give it an angle tolerance that I'll make pretty close to 0. It'll just walk the connected free faces and find this big patch. So I'll just take that patch and say turn that into some geometry. That then leaves me with a middle piece here that I'll grab and turn into another face. And then we can just do the sides, crank them off into geometry on their own. And I'll just grab this one as well. And that was looking pretty good. So let's stitch this together. Parasolid's pretty good at the tolerant geometry thing. So I'll start at full tolerance, and it tells me it's not quite that close, but we can just juice that down a little bit and see that it's connected everywhere but here. So we'll just juice it down a little bit more and see that that's now connected. We've got one nice parasolid sheet body. Now to get these blends back in, I'll probably use our little tool here just to burn a cut line from that point to that point. And same thing on the other side from that point to that point. So right now I've got a nice piece of geometry that represents that former mesh very well. So now let's go ahead and we want to coarsen up a little bit. So I'm going to say mesh control size on surfaces. We're just going to bump this up. We'll go with the default there. And you can see it's a much coarser mesh than we had before. We're going to get a lot less nodes and elements. So let's go ahead and lay down that mesh. And I will just pick my previous property that everything was made out of and let Femap mesh it. Now the neat thing we could do here when we're trying to get the node and element count down is these holes obviously at this point with the coarse mesh to the fine mesh, it's just not a good stress mesh at all, but for dynamics we can clean that even further. So I'll do a feature removal, and I'm going to add a mesh point automatically. So now Femap actually removes that hole but puts a point in and a node, so that later on if we need to grab it there in our system model, we'll have a node at that location. So at this point we've now taken the existing mesh, created geometry, cleaned it up real nice, and have a decent mesh for dynamic type analysis. Just turn off the underlying surfaces. I think you'll see we got a really nice mesh at a much coarser resolution.